Hi everyone, welcome to the Chemistry Learning Channel. I'm very excited to share my passion of chemistry with you, and I hope you'll enjoy this video. In this video, I'll be talking about mass number and atomic number. First, I'll be talking about mass number. Mass number is the number of protons and neutrons in an atomic nucleus. It is often denoted by the capital letter A. Atoms have the same number of protons, but sometimes they vary in neutrons, and these are called isotopes. In the future slides, we'll be working an example with those. And to the image on the right, we have how nickel is commonly written. So the hyphen number next to the element represents the mass number. Atomic number is the number of protons in the atom's nucleus. It is often denoted by the capital letter Z. And as you can see, so it's basically just the diagram of an atom here, and then we have the nucleus, and so this will just count the number of neutrons. The first example we will be working on together is finding the number of protons, electrons, and neutrons in gold. So the question says how many protons, neutrons, and electrons are in 197 AU, which is the symbol for gold, which can also be written AU 197 or 197 AU, like that. So first we'll start off by looking at the periodic table and then finding gold, which is located right here. Then, if we go to the periodic table, we'll see that gold has a Z, which is the atomic number of 79. So, like we said previously, Z is the number of protons. And then A, we can see, is the mass number, which is the number of protons and neutrons. And as per the periodic table of elements, we see that it comes out to 196.967, which is also written in front of the element or in these various ways. So in order to calculate the number of protons, neutrons, and electrons, well, we are given the 79, which is the number of protons. So that takes care of the number of protons. And then since this is not charged in any way, the number of protons is equal to the number of electrons. If there was a charge on the element, then we would need to adjust it. And then for the number of neutrons, we would simply subtract the mass number by the atomic number, which we have done here. So 197 minus 79 equals 118. In this problem, we will be finding the chemical symbol. So the problem says give the complete chemical symbol for the atom that contains 56 protons, 56 electrons, and 82 neutrons. So first, we'll organize what we are given. We are given the atomic number, which is equal to the number of protons, which is given as 56 in the problem. And then we will calculate the mass number, which is the number of protons plus the number of neutrons. We're given 56 protons and we're given 82 neutrons. So since the periodic table is organized by atomic number, we can go to the 56th element, which is barium. And as we see, the mass number is 137.33, which is very close to what we calculated. So we can use that to verify that we are correct. In this slide, I'll be working a uranium isotope example. So the problem says an isotope of uranium has an atomic number of 92 and a mass number of 235. What are the number of protons and neutrons in the nucleus of this atom? So first we'll organize what we are given. So we're given Z, which is the atomic number of 92. And so that is the number of protons that we're solving for here. And then in order to find the neutrons, we'll look at the mass number, which is given to be 235. So 235 is the number of protons and neutrons. If we subtract out the 92 from 235, we'll be left with the number of neutrons. And since this is an isotope of uranium, we'll see that the mass number from the periodic table is different from the mass number of the isotope. And this is because, like we talked about earlier, an isotope is the atom with a different number of neutrons in the nucleus. And we can see that 235 is heavier than 137.3. And so if we subtract out the number of protons, which is basically we're doing the atomic mass minus the atomic number, we'll get the number of neutrons. And that is equal to 235 minus 92, and this gives us 143. And just to sum up our results, we calculated 92 protons from the atomic number, and then when we subtracted the mass number and the atomic number, we got 143. Thank you for watching. If you liked this video, please subscribe, like, and share.